All right, here. So you just watched that really awesome demonstration of Boyle's Law, and you got to see the Stay Puft Marshmallow Man, which was a really scary character for me when I was a wee tot. So here we're going to go over now the relationship that you just witnessed with the demonstration, and then also how to calculate it using the equation for Boyle's Law. So if you remember that any gas law, we have to keep in mind four different variables. That is P, which is pressure, V is volume, N is the number of moles or the amount of gas, and then T is temperature. And for Boyle's Law, we actually keep the amount of gas constant, so we're not going to add any gas or take any gas out of it. And we're going to keep the temperature constant as well. That way, Boyle's Law is strictly looking at the relationship between pressure and volume. Now, when you were looking at that Stay Puft Marshmallow Man, they had it in the bell jar, and so we had all those marshmallows inside of the bell jar, and you could see the guy was twisting the little knob on the side of the bell jar. And what that was doing was taking pressure away from the air inside of that bell jar. So that means that pressure was decreasing. Okay? And then what did you notice about those marshmallows? As the pressure decreased, those marshmallows, or the air pockets inside those marshmallows, actually grew. They increased. So the Stay Puft Marshmallow Man got bigger and bigger and bigger. And then they allowed that pressure to come back in to the bell jar. So that means that they increased the pressure. And then if you notice, those marshmallows actually shrank up smaller than what they did before. So the volume decreased as a result of that increase in pressure. Okay? Now, because when one of these variables goes down, the other goes up, it's not the same as Charles's law. Charles's law, we had a direct relationship. When volume went up, so did temperature. When temperature decreased, so did volume. For Boyle's law, they are the opposites. When one goes down, the other goes up. So we call that an inverse relationship. An inverse relationship. And so then also our gas law equation for Boyle's law is going to be a little bit different than what you saw in our Charles's law demonstration. And it is going to be multiplication instead of division. So it's going to be P1 times V1 equals P2 times V2. And that is exactly what we are going to use here in order to calculate. So let's keep this equation up at the top here. Okay, and then we have a problem that we need to solve. And here it says a sample of gas has a pressure of 4.3 psi and a volume of 2,238 milliliters. If the pressure increases to 7.5 psi, what is the resulting volume? Now I want you to think through this because we have an initial pressure and a final pressure. And that pressure is increasing. So looking at our relationships from before, if pressure increases, then volume should decrease. So keep that in mind when you are calculating, because if you don't get that, that means that something went wrong in your math. All right, let's go ahead and write or plug our numbers in. Let's identify the variables here. So it says a sample of gas has a pressure of 4.3 psi, so that is going to be your P1. In a volume of 2,238 milliliters, so that is going to be your V1. If the pressure increases to 7.5 psi, that's going to be your P2. What is the resulting volume? So I'm looking for my V2 here. Okay, so we've got 3 out of the 4 variables, which is exactly what we want. Now let's go ahead and plug it into this equation here. P1 times V1 equals P2 times V2. So P1 is 4.3 psi times our V1, which is 2,238 milliliters. So just over here, equals our P2, which is 7.5 psi, times our V2, which we don't know, so we're just going to leave that in its variable form. So now we're already set up to go here. We just have to get the second volume all by itself. In order to do that, since it's being multiplied by 7.5 psi, we need to divide each side by 7.5 psi. So now this cancels. I'm left with V2 here. And now to solve this with my calculator. So we've got 4.3 psi times 2,238 divided by 7.5 psi. So you can once again do it all in one step. Okay, and it looks like we're only limited to 2 sig figs because of our pressure here. So we actually need to round 1,283 to 2 sig figs. So if this is our number here, we can only go up to this value right here, so the 2, and the 8 tells us to move that up. So that means that we have 1,300 if we rounded that. These are just placeholders, they're not significant. And then because PSI canceled here, we're solving for volume. Our volume is actually in milliliters for this problem. All right, hopefully that helped. On to the next one.